Hi everyone, this is the video going to discuss with you the topic 1 limit. Here I have a few questions for reinforcement. Let's look at the question 1, evaluate the following limits. Question A, first if we need to evaluate this limit, we need to use the substitution method first, meaning that we are going to substitute the 3 inside. Okay, substitute the 3 inside. Here the x, you have 0 on top, and down here you have 0 below as well. Then if we have 0 over 0, meaning that our substitution is failed. So we need to either go for factorization or we need to go for conjugate. So look at this function. The function consists of the polynomial on top and below. So there is no conjugate over here. We are going to factorize the denominator. So let's see how it works. We have a limit when x approaches to 3. The numerator just remain as a 3 minus x. And the denominator, I'm going to factorize it. Get your 2x, x, and 3, 1. Let's see, is it correct, our factorization? Here is the negative 6x minus x. You get negative 7x. Alright, this is correct. And after that, from here, I can see that I got a 3 minus x on top and the x minus 3 below here. Because they are still not equal, we cannot cancel off. So how can we cancel these two? We just need to factor out the negative from the numerator. Once you factor it out, you have a negative x minus 3 in the bracket. And down here, you still have the 2 factors like that. Now you can see that at the numerator, we have x minus 3. Down here also we have x minus 3. So now we can actually cancel this off. And we have a 1 at the numerator. You can rewrite them. You got a negative 1 at the numerator. And denominator, you have a 2x minus 1. Sorry, this is 1. Okay. Then now, since the x minus 3, which makes you got the 0 over 0 just now you already been cancelled off. So you can actually substitute using the method of substitution. Substitute the 3 inside to evaluate your limits. So put the 3 inside. You got a negative 1 over 5. So your final answer is negative 1 over 5. Okay, let's move to the question B. Question B, again, to start evaluate a limit, we normally will use substitution. Substitute the 1 inside, see what happened on top. If you put the 1 inside here, you will get 0 over here. 0 multiplied by whatever value, you will get 0. Means that for this question, you will get 0 on top. And for the denominator, when you substitute 1 inside, you also will get 0 below. Meaning that now we need to either go for factorization or conjugate. Again, at the numerator and denominator, we only see the polynomial. So probably we need to use factorization. So how do we factorize it? We can see that here is a linear. No more factorization can we apply to. But here will be x squared minus 1 is still a quadratic. So we can factorize this x squared minus 1 into x plus 1, x minus 1. X plus 2 just copy down. And the x squared minus 1 can be written as x plus 1 multiplied by x minus 1. And this is going to be divided by x minus 1, x plus 4. Then now you can see that there is a x minus 1 at the numerator. Can be cancelled off with the x minus 1 at the denominator. So now we already cancel off the x minus 1, which actually makes you got the 0 over 0 just now. Once you have cancelled off this, you can actually rewrite your function. You have your x plus 2 on top, x plus 1 over x plus 4. Now you actually can substitute the 1 inside using the substitution method. Substitute 1 inside, you have a 3 multiplied by the 2 over the 5. So you have your 6 over 5 here. Alright. For the question 2, again, start with the substitution. I got my 0 over 0, if not mistaken. You substitute the negative 2 inside here, you get negative 8, plus 8, you got 0. And down here, if you put in the negative 2, here you will have a negative 4 multiplied by 2, negative 8. Negative 8, this will be positive 8. Positive 8 minus 8, you get 0. So once you get the 0 over 0, means that your substitution temporary cannot be used. You need to factorize first. What can we factorize? We can see that down here we get quadratic. Up here we have cubic. So cubic can be factorized as well as the quadratic also can be factorized. So both denominator and numerator, we also need to factorize it. To factorize this x cubed plus 8, here I will introduce the long division. Alright. For the long division, I'm going to take this x cubed plus 8 divided by its first factor. How do you find the first factor? Since the negative 2, once you substitute negative 2 inside here, you get 0, right? So that means that the negative 2 will be the 0 of this polynomial. If the negative 2 is the 0 of the polynomial, means that the x plus 2 will be the factor. Alright? I'll write it down here. 0 is negative 2, means that the factor will be x plus 2. So I'm taking this polynomial x cubed plus 8 divided by x plus 2. Alright, using this long division, I got my x squared. You have your x cubed plus 2 multiplied by x squared, you have a 2x squared. How do we get this x squared? You just ask yourself, x multiplied by what to get the x cubed? Because you are going to eliminate the x cubed. So you need to get something multiplied by x in order to get this x cubed. So we know that x squared multiplied by x, you get the x cubed. After this, you minus the original function with the function that you have. You got 0 here. X cubed minus x cubed, you get 0. 8 minus 2x squared, you get a negative 2x squared plus 8. I always will put my term with a higher order of x, okay, higher degree of x at the front as a leading term. Alright, so I'm not going to put the 8 as a leading term. Okay, here you can see that I put a negative 2x squared, then only I will put the 8 behind it. Alright, after this, you still can use the negative 2x squared divided by x. Look at the head and the head here, the leading term and the leading term here. So what multiplied by x to get the negative 2x squared? You have your negative 2x. Because negative 2x multiplied by x, you have your negative 2x squared. Then negative 2x multiplied by 2, you have negative 4x. Alright? Then again, you minus. Okay? So this leading term after minus, you get 0. 8 minus negative 4x, you have a positive 4x plus 8. Okay? Then 4x divided by x, you get a 4. Because 4 multiplied by x, you have 4x. And 4 multiplied by 2, you get positive 8. Means that you will get the remainder 0. Of course, you will get the remainder 0 because this is the factor. Alright, so you can say that now x cubed plus 8 consists of the multiplication of the divisor, that is the factor, multiplied by the quotient, that is my x squared, minus 2x plus 4. And this is divided by, now we can just, this is very easy to factorize. We can just directly factorize it. You factor out the 2x, and you have your x in the bracket and the 2 plus 2. So what can you see that is x plus 2 appear in the numerator and also denominator. And this is the things that will make us get 0 over 0. Because when you substitute negative 2 inside, you get 0 here and you get 0 here. This is the things that make us makes the substitution fail. So now you can just cancel this off, and now substitution can be applied. You can substitute negative 2 inside. You got negative 2 power of 2 minus 2 multiplied by negative 2 plus 4 divided by 2 multiplied by negative 2. Finally, you get negative 3 for the final answer. For the question 2b, here again, I'll apply the substitution. I got 0 on top. And here, if you put 5 inside, you have 15 minus 12, that is cert 3. Cert 3 minus cert 3, also you will get 0. So now you can see that up here we got a polynomial, quadratic. Down here we got something in the form of cert. So probably for this question, we need to apply both factorization and also multiplication of conjugate. So for this question, here I need to consider the conjugate. The conjugate of this denominator will be cert square root of 3x minus 12. Just change the sign of this, plus square root of 3. And you must multiply the same thing on top, so that this become 1. This is actually equivalent to 1 because a over a is equal to 1. That means that you're not changing the original function. Alright, after you have done this, you just expand the denominator. We are not going to expand the numerator. Remember, we are not going to expand the numerator. We just use the bracket to separate them to show that they are multiply each other. Okay, so for 25 minus x squared, you can actually, if you can see, you can actually factorize it first. You got your 5 plus x, 5 minus x, and multiply by this square root of 3x minus 12 plus square root of 3. And down here, we're going to expand so that the third term will be eliminated later on. Square root of 3x minus 12 multiplied by square root of 3x minus 12, you will have a 3x minus 12. And the middle term will be cancelled off each other because square root of 3x minus 12 multiplied by cert 3 minus cert 3 multiplied by square root of 3x minus 12 will be 0. And a negative cert 3 multiplied by positive cert 3, you get a negative 3. Alright, so once you multiply by the conjugate, you can see that the term with the square root will be eliminated. Alright, so now you need to simplify. And later on, find out anything can be cancelled off. You got the 5 plus x, 5 minus x. This is plus 3 over 3x minus 3x. Here you got a 3x minus 15. 3x minus 15, I can factor out the 3. If you factor out the 3, you will have x minus 5. See or not? So now, you don't say that the x minus 5 can be cancelled off with 5 minus x because they are not the same. Alright? So now, how do we change it to be the same? Again, I'm going to factor out the negative maybe. Numerator, I just fix as this. I'm not going to change it. Or you may factor out the negative from the top, also can. But here now, I will factor out from here the negative. I factor out the negative, I got my negative 3. And then here you may have your 5 minus x. Alright, when you expand back, you should get back the same thing. Okay, so now I can see that numerator appear the 5 minus x and as well as this denominator. So now I can actually cancel this out. And you can see that the 5 minus x, this factor actually is making our function to be 0 over 0. Okay, which will make our substitution fail just now. So now, once you have been cancelled off this, then you can actually apply back the substitution method. Substitute the 5 inside, you have your 10 multiplied by 15 minus 12, you have your cert 3. Cert 3 plus cert 3, you got 2 cert 3 divided by negative 3. So we have your negative 20 cert 3 over 3. Alright, for this question, again, I'm going to apply the substitution first. Substitute the 9 here, you get 0 on top and 0 below. So again, I'm not going to apply substitution first. Alright, we will actually finding the conjugate for this numerator. I have my cert 3, cert x. plus 3. This is the conjugate. And the same thing, you need to multiply at the denominator so that this becomes 1. So now after you have set this, you can expand the numerator, expand the conjugate only. Down here, I'm not going to expand. I would just put bracket to show they are multiplied with each other. This is your x plus 3. So here, if you expand, you will have x. And the term which containing the third in the middle will be cancelled off each other. And you have your negative 9 here. So again, you can see that x minus 9 on top and 9 minus x appear in the denominator. So it cannot be cancelled off yet as you haven't changed it exactly equal. Alright, so if you want to make it exactly equal, you need to factor out the negative so that you have your 9 minus x. So now you can see that you have a 9 minus x at the numerator. And the denominator also 9 minus x. So you can now just cancel this off and you have a negative 1 on top. If you want to rewrite them to make it clearer, you can do so. Or you can direct substitute the 9 inside. So on top here you have negative 1. And below you have your square root of x plus 3. Alright, so now you can substitute the x equals to 9. Substitute the x equals to 9 inside here. You got your answer for this limit. So when you put in the 9, you got the third 9 equals to 3. 3 plus 3, that will be equals to 6. The answer is negative 1 over 6. For this question, again, we are going to substitute. See if you got the 0 over 0. Okay, just put in the 0 inside here. You got third 2 minus third 2. Yes, you got 0 on top. And if you put in the 0 in here, you got the 0 below. So this you need to multiply by the conjugate. The conjugate is your square root of x plus 2 plus third 2. And you need to do the same at the denominator. You get the same thing to be multiplied at the denominator. And now you are going to expand the numerator only because just expand the conjugate. Alright. The denominator, just use the bracket to show they are multiplied. Do not expand. Alright, do not expand. Just expand the conjugate. You got the x plus 2. And the term in the middle can be cancelled off each other. Then minus third 2 plus third 2 multiply. You got negative 2. So now you have your x plus 2 minus 2 on top. You can actually just eliminate the 2. And the x down here can be cancelled off with the x at the numerator. You can see that this x can be cancelled off. And once you cancel off, still it will be 1 on top. Okay. After that, you can direct substitution. Substitute the 0 inside. You have a 1 over third 2 plus third 2. That will be 2 third 2. Okay, this is the answer. You might think that you need to present your answer in the simplest form. So you can actually multiply this by the third 2 over third 2 so that you can rationalize the denominator. Rationalize denominator meaning that you will make the denominator without the third. Alright, without the irrational number. So here, up here, you have a third 2. Down here, you have a third 2 multiplied by third 2. You have your 2. 2 multiplied by 2 here will be 4. Alright, so this will be the answer in the simplest form where the denominator is already being rationalized. For the question 4a, again, substitution first. Substitute 4 inside, you got 0 on top. And substitute 4 here, you got 2 minus 2, 0 below. Again, I decided to multiply by its conjugate. The conjugate will only appear for the third. So you have your 2 plus third x. And on top, you multiply by the same thing. So now you can start to expand the denominator only. Do not expand the numerator. Numerator, you just put the bracket to show they are multiply each other. That's it. Alright. Then down here, you need to expand 2 multiplied by 2, you got 4. Plus positive 2 third x minus 2 third x, you get 0. Negative third x multiplied by third x, you have your negative x. So why I ask you not to expand the numerator, because that now you can see that actually you can cancel off the 4 minus x. Once you cancel off the 4 minus x, you can start to substitute the 4 into the x to evaluate your limit. So you can start the substitution. You got 2 plus 2, that will be equivalent to 4. To evaluate this limit, alright, it's just similar to what we have done just now. When you substitute the 2 inside, you have your 0 on top and 0 below. So now I'm going to do the factorization and also the conjugate both. For the numerator, I got polynomial. So this is a cubic polynomial. I need to use the long division to help me to factorize. And the denominator, I can actually multiply by its conjugate. The conjugate will be square root of x minus 2. And we will do the same thing on the numerator. Alright, so to factorize this, we can get prepared of the long division. This is divided by the first factor. If the 0 is 2, why I say the 0 is 2? Because when you substitute the 2 inside here, you got 0, means that the 0 is 2. Alright, if the 0 is 2, meaning that the factor will be x minus 2. So I will take this polynomial divided by x minus 2. I got my negative x squared. Okay, you got your negative s cubed, and negative x squared multiplied by negative 2, you got positive 2x squared. Once you have done this, you're going to minus it. Alright, this leading term minus, you will get 0. And here you got 8 minus 2x squared. What you left is 8 minus 2x squared. And I'm not going to write the 8 minus 2x squared. I'm going to put the negative 2x squared as a leading term plus 8. Alright, because it's easy for me to do the division for the next step. Negative 2x squared divided by x, you have your negative 2x. Because negative 2x multiplied by x, you have your negative 2x squared, which is exactly the same as this. Alright, and negative 2x multiplied by negative 2, you got positive 4x. Once you have done this, again you minus. Alright, so the leading term after the minus, you get 0. And you got 8 minus 4x. Again, I will put a negative 4 as my leading term, plus 8. Then now you can see that negative 4x divided by x, I will take this as a negative 4, because negative 4 multiplied by x, you got negative 4x. And negative 4 multiplied by negative 2, you got positive 8. And of course, you will get the remainder 0, because x minus 2 is the factor of this polynomial. So now you can see that you got a quotient in negative x squared, negative 2x minus 4. Means that the quotient multiplied by this divisor will get back your polynomial. Then you can write it here. You actually can substitute this 8 minus x cubed as a x minus 2 multiplied by negative x squared minus 2x minus 4. And this is going to be multiplied by square root of x minus 2. Remember, not to expand. Alright, we only expand the conjugate. So when you multiply square root of x minus 2 by the square root of x minus 2, you should get x minus 2 only. And now we can see that here you have the x minus 2, here also you have the x minus 2, cancel off each other. You got your, you left this one. And now you can substitute the value of 2 inside to get your limit. Okay, substitute the 2 inside, you got a negative 4 minus 4 plus, negative 4. And this is going to be multiplied by 2 minus 2. Alright, when you substitute the 2 inside here, you get a 0. So the answer is 0. And 0 is a defined, and we don't feel doubt when you get 0, you are not sure that your answer is correct. Alright, limit doesn't promise to you the value must be non-zero. So limit can be 0. 0 is also a defined number. So this is the answer is 0. For question 5, I got a piecewise function. Alright, then now we need to get the limit when x approaches to 4. When you have a piecewise function like that, you need to do one-sided limit. to find the limit when x approaches to 4, you need to find the limit when x approaches to 4 from the right, and also the limit when x approaches to 4 from the left. That is 4 negative. And you need to put in the fx, which is corresponding to their limit, to your, what we call the interval. So when x approaches to 4 positive, you can imagine the 4 positive is a value greater than 4. Alright, so the value greater than 4 is 4 in the first quadrant, first interval. So I'm taking this function, fx, okay, taking this to represent my fx. And now we can actually use the substitution method. After we substitute, we still will get 0 over 0, right? So you know you need to factorize this. X cubed minus 64, you can factorize it by the long division again. Alright, you can take the x cubed minus 64 divided by the first factor. The first factor will be x minus 4. Alright, because when you substitute 4 inside, you get 0. So the 0 will be 4 and x minus 4 will be the factor. So very quickly, we'll do the long division. From the long division, I have my quotient. So you can write your limit, your function, in this form, x minus 4. Your polynomial, x cubed minus 64, can be written as x minus 4 multiplied by x squared plus 4x plus 16. And this is going to be divided by x minus 4. After that, you can cancel off this. And now you can just substitute the 4 inside to get your limit. For the right hand limit, I got 648. Alright, then now you might try to get your left hand limit by substituting the corresponding function inside, because 4 negative, you can see that the 4 negative might be 3.99999. Just ask yourself, 3.999 is 4 at the first interval or second. Alright, 3.999 will be here. So you will take this function as your x cubed minus 64 over x minus 4. Okay, we do not need to do the second time long division because we have did it just now. X cubed minus 64, you can just substitute what you have did just now. You just put in your factorized form divided by x minus 4. Again, do the same thing. Cancel off the x minus 4 and substitute the 4 inside. Now you get a 4 squared plus 16 plus 16. Again, you have your 48. Alright, once you have the right hand limit and left hand limit, you can make conclusion. Since the limit when x approaches to 4 positive is equals to the limit when x approaches to 4 negative. This is a reason. Is both equals to 48. Then we say that the limit when x approaches to 4, that is a two-sided limit. This is a two-sided limit equals to 48. Alright, when you have a piecewise function, you must show the right-hand limit is equal to the left-hand limit. Then only you can say that your two-sided limit, that is x approaches to 4, is exists, and it is equals to the value that equivalent by the right-hand limit and left-hand limit.